So, good noon to all. Today we are going to start module first, complex numbers in mathematical methods in physics. So first of all, complex numbers have a great importance because these numbers are not only used in mathematics but also in physics and engineering sciences. In physics, approach with the use of complex numbers gives an easy solution or interpretations involved in situations of analytical treatment of AC circuits. So before going to start the complex numbers, we will see some quadratic equations as you have seen in your 8th and 10th standards in algebra. So first of all, we will go towards the quadratic equations. So what is meant by quadratic equation? Everyone knows the basic formula for quadratic equation as basic formula ax square plus bx plus c is equals to 0. We can write instead of x az square plus bz plus c is equals to 0. In this we can find out its roots by the to find out the unknown values of x or y here. So the roots of this quadratic equation are z is equals to minus b plus or minus b square minus 4ac upon twice a. These are two roots of this quadratic equation. Here the square root value b square minus 4ac is the discriminant. So by finding out the value of discriminant, we can get the roots of quadratic equation. We can take one example over here. Suppose we have taken one example quadratic equation for z square minus 20z plus 15 is equals to 0. So we have to find out here its roots of this quadratic equation by using the finding the value of discriminant. So the discriminant value here is b square minus 4ac. If we have taken the value of b here 20 squares minus 20 square is 400 minus 4 into value of a is here 4 into 15. So we will get here the discriminant value is 160, which is a positive. So we can get its roots of a quadratic equation, that is z is equals to minus b means minus 20, it is 20 plus or minus square root of this is 160. Discriminant value is 160 divided by twice a, it's 2a means 8. So if we solve, z is equals to 20 plus or minus square root of if we solve it as a 4, 16 multiplied by 10 divided by 8. So we will get its value 20 plus or minus 4 into square root of 10 divided by 8. By dividing 4 numerator and denominator, here we get 5, here 1, this is 2. So we will get z is equals to 5 plus square root of 10 divided by 2, and another z1 and z2, another root is 5 minus square root of 10 divided by 2. These are the two roots of this given quadratic equation. So these roots are irrational numbers. Here again we will see one example. Here we can get another example. We will take another example here. Suppose 4z square minus 20z plus 27 is equals to 0. We have to find out its roots. So here the discriminant value is, we can find out the discriminant value. B square minus 4ac, which is, we can calculate by putting the values of this. It will be minus 32, which is a negative. So the square root of negative number, it is a meaningless. So we cannot get the square root of a negative number. So these roots are neither rational or irrational real numbers, because there is no meaning for a square root of negative integer. So the square root of negative integer cannot be found out by usual method in algebra. When discriminant is negative, the square root of discriminant value can be obtained by introducing a new kind of number called as imaginary number. So here we can put this imaginary number as a I. Suppose this is I and its value is square root of minus 1, or I square is equals to minus 1. So we will get the roots of this quadratic equation. So here we can put the value of this. Z is equals to, we can directly find out here roots 5 plus or minus square root of I square 2 divided by 2. Here we can put the value of I square is a minus 1. So therefore Z is equals to 5 plus I square root of 2 divided by 2, and another root Z is equals to minus I square root of 2 divided by 2. So these are the two different roots of this quadratic equation, and these numbers giving the roots of the quadratic equation are known as complex numbers. These numbers contains, here we can see this number contains the real part, this is the real part, and this is the imaginary part. So in quadratic equation, or roots of this quadratic equation, that is complex numbers, contains a real part as well as imaginary part. So the basic, we can form the basic definition of complex number. Z is defined as the Z is equals to x plus iy. Here x is the real part of this number, and here the iy is the imaginary part of this complex number. So complex number forms with the real part as well as imaginary part, with the I is the imaginary number here, which is value is I equals to square root of minus 1. So we can take some examples of complex numbers here. So here, before going to take one example, here the real part of this complex number Z is x, and imaginary part of this complex number is y. For example, we can take here one example. If Z is equals to 5 minus 7i, so here the real part of this complex number is 5, means suppose we can correlate as x plus yy. So here x, value of x is a 5, and here imaginary part of this complex number is -7, that is y is equals to -7. So again, if the real part if the complex number having real part is 0, then z is equals to iy, that is the complex number is purely imaginary. And if suppose the complex number having its imaginary part is 0, then z is equals to xy, means it's a purely real number. So again we can see the second terminology, modulus of complex number. We can have, suppose complex number z is given as z is equals to x plus iy here, then its complex conjugate is z bar. We can find out its complex conjugate as z bar is equals to x minus iy. Imaginary numbers would be changed to negative as x minus iy. If we multiply by complex number and its complex conjugate as z into z bar, that is over here x plus iy into x minus iy, by multiplying these factors we can get x square plus y square here. The product of z and z bar is always positive. The product of z and z bar is given as the mod of z square. Z square, mod of z square is equal to x square plus y square, and the quantity mod z is called as the modulus of complex number z, or we can say again mod z. Thus the mod of z is equal to the square root of x square plus y square. By using this formula we can get the mod of z or modulus of z of any given complex number. Here we can take one example to find out its modulus of this number. So for mod z we need to consider z into z bar. So here we have already a complex number z. We need to find out its complex conjugate of this given complex number. Its complex conjugate z bar is equals to 3 plus 2i. So therefore mod of z is equals to square root of, we can find two different ways. Here we can just z into z bar, here 3 minus 2i into 3 plus 2i this way. Otherwise by using the formula of x square plus y square, here x is the real part of this complex number is 3 and imaginary part of this complex number is a -2, we can take here. So the square root of x square is 9 plus -2 square is a 4. So this is the square root of 13. This is the mod of z or a given complex number, modulus of complex number. So we can see some different terminologies or some algebra of complex numbers here over here. First of all, we can see the equality of complex numbers. So how two complex numbers are equal, or when we can say these two complex numbers are equal? Suppose consider here over here, consider two complex numbers. Consider two complex numbers. First one is z1 is equals to x1 plus iy1, and next z2 equals to x2 plus iy2. So when these two complex numbers are equal, we can say or are said to be equal if and only if their real as well as imaginary parts are equal. Imaginary parts are equal. Then we can say that these two complex numbers are equal. Otherwise these two complex numbers are not equal, means here if and only if this real part of these complex numbers are equal and this imaginary part of these two complex numbers are equal, then we can say that the given two complex numbers are equal. Again we can see the next algebra of these complex numbers, addition of the two complex numbers. Here we can consider again these two complex numbers. So we have to add these complex numbers z1 plus z2, that is we can put here its values x1 plus iy1 plus x2 plus iy2. So here by adding the real part and imaginary part of these complex numbers we can get the addition. So here this imaginary part as well as this real parts we can add here x1 plus x2 plus I into y1 plus y2, means addition of the imaginary parts. So we will get the addition of these two complex numbers. Similarly we can go or see the subtraction of these two complex numbers. Similarly z1 minus z2 x1 plus iy1 minus x2 plus iy2. So here again we have to add its real part, subtract real parts, x1 minus x2, okay, minus iy1 or plus iy1 minus y2. So we will get the subtraction value of these two complex numbers. So in the next part we will see again algebra and some relations between the complex numbers. Thank you.